All right, so let's do example 1 for Lagrangian error. I need to write bigger. Sorry about that. But that says example 1 for Lagrangian error. So let's do it. Again, the Lagrangian here must be less than or equal to the maximum value of the n+1th derivative on the interval from c to whatever x you want to be choosing here. We have x minus c to the n+1 over n+1 factorial. So that is our Lagrangian. Let's try it out. So, for example, let's use f of x equaling the natural log of 1 minus x, okay? And I want to find what is the Taylor polynomial. So let's find the Taylor polynomial of order 3. Okay, again, order 3, centered on, let's do, 0. That makes sense. Okay, so first off, let's figure out some of these derivatives. So, by the way, f of 0 is in fact natural log of 1, which is 0. F prime of x here is the derivative of this, which is 1 minus x to the negative 1, because that, and then the derivative of what's inside, which is negative, so there we go. In which case, when I plug in 0, I get negative 1, right? Then let's do the second derivative. Second derivative here is bring the negative 1 down. That's going to now make that positive. This will now become 1 minus x to the negative 2 times the derivative of what's inside, which is another negative 1. So that's great. What about the third derivative, though? Well, in this case, now we're going to go up to positive 2 when we multiply that down. 1 minus x to the negative third times the derivative of what's inside. This is now negative 2. I'm going to do the fourth derivative just because we need to know the maximum here. So the fourth derivative, bring that down, becomes negative 6, 1 minus x to the negative fourth. So let's do, we're going to be centered at 0. Let's plug in negative 1. So I want to find the Lagrangian error at negative 1. So if I plug in 0, this is negative 6, right? If I plug in negative 1, that's going to be 2, but it's going to be on the bottom. So this is going to be a much smaller, the absolute value of this is going to be much smaller if I plug in 2. In fact, that's going to be true from the interval from 0 to negative 1. And so 0, x being 0, is actually our maximum. So f of 4, we'll write max down here of x is in fact negative 6, but we actually only care about the absolute value of it anyway. All right. Sorry, I should have put that in there. Okay, so let's do this. Oop, you couldn't have seen that. All right, 4 through, right, so we're at the max of negative 3. All right, so our polynomial, so here's f of x. F of x, again, is the natural log of 1 minus x. P of x now is going to equal, well, 0 minus x, centered at 0, so it's just minus x over 1, so that's just it. Then the next one is minus x squared over 2, and the last one is minus 2x cubed over 3 factorial, or 6. So in fact, we will actually get negative x minus x squared over 2, 6 divided by, so this is just over 3, so this is minus x cubed over 3. Great, so here's our polynomial. So what is our Lagrangian error for the fourth term? Well, our Lagrangian error, so we're going to do our Lagrangian error here, and again, we're looking at x equals, we're going for negative 1, right? So our Lagrangian error here at x equals negative 1 must be our maximum value in between the two, which is -6. We don't care about the negative because we just want the error, right? We don't care whether it's positive or negative. So let's just put in 6. Then x minus c, in this case, it's -1 minus 0 to the power of 4 over 4 factorial. This then means, well, this just goes to -1 to the 4th, goes away. 6, that's 3 factorial, by the way. 3 factorial over 4 factorial is, in fact, just 1/4. So we are going to be off by 1/4. Let me go and run and get my calculator really fast to prove this to you. But basically what we're saying is that p of -1 minus f of -1 must be less than or equal to 1/4. Plugging in -1 here gives me -1, -1. So that's actually just going to be, oh, am I off the screen again? I am. I'm sorry about that. There we go. P of -1 minus f of -1 has to be less than or equal to 1/4, which is what we said. So if I look up here at my polynomial, plugging in p of -1 equals 1. That at -1/2. Then when I plug in -1 here, that is in fact negative, so that actually cancels out. So plus 1/3, okay? F of -1, f of -1 is in fact the natural log of 1 minus -1, which is the natural log of 2. So let's check. There we go. Perfect. So let's make sure this is actually true. So that's 1/2 plus 1/3. So 0.5 plus 1/3 here. So we get that. So this is 0.83 repeating. And the natural log of 2 is 0.69. You can easily tell that 0.25 does not, the difference between these two is less than 0.25. So this works. That was our Lagrangian error, by the way. So that's our example. Thank you.